Exercise 13.2, just looking at some more questions. So to differentiate sine of 2t plus pi on 2. So if y is the sine of 2t plus pi on 2, dy, what do I write? dy dx, dy dt, dy d what? dy dt is, differentiate sine, you get cos, times the derivative of just what's inside, which is 2. No, this is correct. So, because if you differentiate 2t plus pi on 2, you get 2, and pi on 2 is a constant, and you lose that. So it's just 2 cos 2t plus pi on 2. Look at our derivatives of cot x, sec x, and cosec x. There are no rules for that on your formula sheet. So if we've got y equals cot x, I did look at this one did do it on the board the other day. But I showed you 2 different methods of doing that. I think the better method is to write it in terms of cos and sine. Remember that tan x, is sine x on cos x. So what's cot x? It's the reciprocal of that, which is cos x on sine x. See, I think you should do the derivative of this one this way, but you can do it another way as well. So I would use the which rule? Quotient rule, vu dash minus uv dash over v squared. So just remembering tan is sine on cos, so cot is cos on sine, the reciprocal. U is cos x, we did do this quickly last lesson, and v would be sine x. So u is cos x, u dashed is what? Come on. Differentiate cos. Yep. V is sine x, v dash is cos x. Substituting into the formula, you've got sine x times negative sine x. So sine x times negative sine x minus, or take away, uv dash is cos x times cos x. Oops, sorry. Cos x times cos x. V squared is sine x squared, which is sine squared x. So what have we got here? Sine x times negative sine x. Isn't that negative sine squared x? What else? Take away cos squared x over sine squared x. What should I do with these negatives? Because what's the result that you know, sine squared x, between the relationship with sine squared x and cos squared x? This is what we know, that sine squared x plus cos squared x equals 1. Okay? So if we pull out the negative common factor here, we've got negative bracket sine squared x plus cos squared x over sine squared x. What do we get? Negative 1 on sine squared x, which is negative cosec squared x. Now that's one way to do the derivative of cot x. Now I know that the textbook has that result. You are not to use that result. If you're asked to differentiate cot x, you need to either do it that way or the other way. I'll do it as well. The other way is to write cot as 1 on tan. Okay, so that's one way to differentiate cot x. The other way is to write cot x as 1 over tan x. We did look at this quickly last lesson, which is tan x to the power of negative 1. So let's do it that way as well. So what have we got? Dy dx equals, this is the other way. What do we do? Anyone? Okay, now, what do we do? If you're asked to do something to a power, how do you differentiate it? Don't you bring the power down? Negative 1 tan x. So I go negative 1 bracket tan x. Don't I drop this power by 1? To the what? Drop negative 1 by 1. To the negative 2 times, what do I do now? The derivative of tan x is? Come on. Sec squared x. So we bring the negative 1 to the front, bracket tan x close bracket, drop this power by 1, then times the derivative of tan x, which is sec squared x. Girls, remember there's 3 rules and they are all on your formula sheet, and they are: if y is sin x, dy dx is cos x. The other one is if y is cos x, dy dx, or y dash is negative sin x. The other rule on your formula sheet is if y is tan x, it actually does the function tan a function of x, you get sec squared x. Okay, so differentiate tan x, you get sec squared x. So that's negative 1 over, what do I write? How do I write tan x? Negative power means it's on the denominator. Tan x squared is really tan squared x. Are we okay with writing it like that? Times sec squared x. How do I simplify this? Yeah, it's sec squared x on tan squared x, but isn't it? Well, instead of writing that down there, I can write it up here. I can write negative cot squared x times sec squared x, but how do I simplify that, girls? Come on, what's cot? The reciprocal of tan. Now, tan is sine on cos. So what's cot? Cos on sine. So that's the same as negative cos squared x over sine squared x times, what's sec? Third letter, 1 on cos squared x. So girls, look, I didn't have to write that as cos squared x. It's the reciprocal of tan squared x. So I know tan squared is sine squared on cos squared. I could have just gone straight from there to the reciprocal cos squared on sine squared. Because this is the reciprocal of tan, it's 1 over tan. Tan is sine on cos, so 1 over tan is cos on sine. Okay, or you can write it like that and write out the ratio. And we know that sec is 1 on cos. So why have I done this? What cancels? Yeah, what cancels? What? The cos squareds cancel between the numerator and the denominator. And I've got negative 1 on sine squared x, which is, what's 1 on sine? Cosec squared x. Remember, it's the third letter of cosec is an s, so it's the reciprocal ratio for sine, and it's negative, by the way. It's negative because it's negative 1 on sine squared x. So it's negative cosec squared x, sec x. So y equals sec x, which is what? What's sec? Third letter is C, 1 on cos x. So I still can't differentiate it. The only thing, I can't differentiate a 1 over cos x, so how am I going to change that? How am I going to write it? Cos x to the negative 1. Okay? So if you're asked to differentiate sec x, you need to write it as 1 on cos x, and then you need to write it as cos of x to the power of negative 1. Now I can do my derivative. So what do? Bring the negative 1 to the front. Write out the cos x. So bring that to the front, write this out, drop the power by 1. So negative 1 minus 1 is negative 2 times the derivative of what's inside, which is? Good. So how do I write this? A negative times a negative is a positive. So I've got sine x times, oh, no, not times. So that is that. What do I do with this cos x? Where do I put it? On the denominator. I can write it as cos x squared. Are you okay? Cos of x to the negative 2 means 1 over cos x squared. What do I do with, how do I write that nicely? Yeah. Now, you know what I want to do? Instead of leaving it like that, I can leave it like that. Another thing that I can do is, I know that sine on cos is tan, don't I? So I'm going to put sine x on cos x. What do I still need to write? What am I missing? I need another cos on the denominator. Okay, so I could write my answer like this as well, which is, are we okay with this, girls? So when you see that, you can simplify as sine x on cos x, because that's really sine x over cos x times cos x. But you break it up like this because you know that sine x on cos x is what? Tan x. And we know that 1 on cos is sec. So that's what that is, tan x times sec x. And the last one, if y is, which one haven't I done? Cosec x, find dy dx. So cosec x, let's use the same method as what we've just used. Okay, so we're going to try that one. So we've got y is cosec x. How are you going to write it? Cosec, we write it as 1 on sine x, which is sine x all to the power of -1. And now we can, now that it's in a form that we can differentiate, we start to differentiate it. With differentiating, we bring the -1 to the front, write it out, drop the power by 1 times the derivative of sine x, which is just an ordinary cos x. So this is on the numerator, I've got negative cos x over on the denominator, I've got sine x all squared. Now, you can do what we did before. So I'm going to write it as negative cos x on one of the sine x's times another 1 on sine x. Are we okay with that? What's cos on sine? Because we know that sine on cos is tan. What's cos on sine? Cot. So it's negative cot x. And what's sine? Cosec. Because of the third letter of cosec is s, so cosec. Okay? All right. Differentiate. This is cosec x squared minus 1. It's question 5M. I don't want you to use the rule that they've provided. So how would you write this as? 1 over sine x squared minus 1. We'll write this as sine of x squared minus 1, put some square brackets as well, to the -1. Okay, so that's what that is. So now the derivative is, so if anyone's waiting for another one, you can, if you've done that, you can try this one. Y is cot squared 2x. That will be the next one after we've done this one. That's question N. Okay, what are we going to do? What's our rule? Bring, it's not too bad, bring the -1 to the front, isn't it? Write it out. Drop the power. And then differentiate what's inside. But be careful here, because you've got to differentiate what's inside and differentiate what's inside that bracket too. Because now just pretend you've been asked to differentiate sine of x squared minus 1. We've done that. Bring this to the front, write it out, drop the power by 1. Now just focus on differentiating what's inside. What do you get? Cos of, come on, x squared minus 1 times the derivative of that, which is 2x. Please, we know that. Bring that to the front, write this out, drop the power by 1, times, differentiate what's inside. So if I asked you to differentiate sine of x squared minus 1, you write that differentiating sine is cos, but because this is a function, you need to differentiate the function inside. Okay? So then we've got, let's look at our numerator. What have we got on the numerator? So this -2 one, that goes down the denominator. What have I got on the numerator? -2x cos of x squared minus 1 over, isn't that just this squared on the denominator? So instead of, I can go sine of x squared minus 1 all squared, but how do I write that in a better format? -2x cos of x squared minus 1 over sine of x squared minus 1. And I can go times, look, I could just put the squared there, but if they want it further simplified, so I could just put the squared there if I want. Oh, actually, I'll write that here. -2x over cos of x squared minus 1 over sine squared x squared minus 1. Now I'm going to simplify it. What do I need to write here? 1 over. So that and this are the same. If I want to change the, because I've got cos over sine squared, I can further simplify that. What do I do? Cos on sine. What do I write here? I've still got one more of them. Look, I can't see why this can't be an answer, all right? But you may be asked to show that it's something else. So cos on sine squared x, that still can be simplified. So you would just do the negative 2x cos on sine one of them, and the other sine is here. So what have I got? Negative 2x. What's cos on sine? Cot. So it's just the cot of that times, what's 1 on sine? Cosec. Next one, just set it up. So how are you going to set it up? What's cot? 1 on tan. 1 on tan. But I can't, or instead of putting the squared like that, you can go like this. You okay? Or I can put the squared there. It's the same thing. All right, so I could have written it like this, tan squared 2x. But to put it like that is better. So you could go from there to this and then to that. Why do I want to put this 2 on the outside? Because it helps me with differentiating. So now what do? My rule is not to differentiate tan on the denominator. The tan needs to be on the numerator. So how do I bring that up to the numerator? Tan of 2x to the negative 2. Okay? So cot squared 2x is 1 over tan squared 2x, which is 1 over tan 2x to the power of 2. Bring it back up. Now you can differentiate. See, whenever you're differentiating, it has to be something to the power of n, not 1 over something to the power of n. You can't do that. Okay? So what have we got? So that's what y is. So you have to take those steps before you start. Derivative, bring the negative 2 to the front. Write it out. What's my new power? Times the derivative of tan of 2x. Yeah, it's sec squared 2x times differentiate the 2x and you get 2. See, the differentiating the tan of a function is the sec squared of that function times the derivative of that function. So what have I got on my numerator? So this negative 3 one is going to be on the denominator, right? So what I've got on my denominator is tan of 2x cubed, okay? Now what's left on my numerator is negative 2 times 2 is negative 4 sec squared 2x. To simplify this, so I've got negative 4 sec squared 2x. Now I can write divided by this, or I can stick this back up onto the numerator, but not as a tan, but as a what? This is 1 on tan. What's 1 on tan? The fact that the tan of 2x is on the denominator, guys, 1 on tan is what? Cot. So I can move that back up as a cot. Tan, which is cot. So I can go times and bring it up to the numerator, cot of 2x cubed, which is cot cubed 2x. Instead of writing cot of 2x cubed on the outside, it's cot cubed 2x. Let's keep going. Negative 4. What's sec? 1 on cos. So I can just write the cos down the denominator. What's cot? Not sine on cos. It's cos on sine. So it'll be cos cubed 2x over sine cubed 2x. Okay, we're getting there. What cancels? How many of the coses cancel out? 2 of the coses cancel out with 2 of these. So I'm still left with 1 cos 2x on the numerator. And how many sine 2x's on the denominator do I have? Sine cubed 2x. Are we good? Now what do you think you should do? Yes, cos on sine is cot. So let's put 1 of the sines with the cos and put the other 2 sines here. You good with that? And now, what's cos on sine? I just hope I don't end up with what I just had. And I have a feeling I bet I will. I do. Yeah. I stop here. Done. That's done. Look, watch what's going to happen. -4, what's cos on sine? Cot. And what's 1 on sine? Cosec. Oh. Sec? Cosec. Oh. Wait. Oh, no. Okay, it's just a different answer. Wait, oh, no, it's okay. That's it. Reason they say differentiate with respect to x is that the function is in terms of x. So I'll ask you to differentiate this, for example. Now, because I haven't written function of x equals or y equals, I can go like this, d by dx of this. Do you know what I mean? Equals. Or I can write if y equals dy dx equals. All right? But this is what, so if they don't tell you that y equals function of x equals, you go d by dx of that equals. And if you're not comfortable with that, just write let y equal that, then dy dx equals. All right? Are we okay? So, or I could write if y is this, dy dx is, etc. Or I could have written if function in x is, this is just for your setting out, f dashed x is, and then you would do it. The other way, so you could write it like this if you're not comfortable with that, or you write the derivative of d by dx is telling me I'm differentiating this with respect to x. Now that is, how do I, before I do that, it's the derivative. I can't do it like that. I need something to some power. What's square root? What power is that? Half. And once you've written it like that, so if you're asked to differentiate this, so I want the derivative of this, it's the same as the derivative of that. Now you can apply your rule. So once you start differentiating, you drop that d by dx. All right, what do? You bring the half to the front. You write out your cos 2x. The reason I'm putting the cos 2x in brackets, I don't want it to look like I've got x to the power of something. It's this whole thing is to the power of. Aren't you dropping this by 1? It's -1/2 times the derivative of what's inside. Good. Differentiate cos, you get negative sine times, it's just not the sine of x. You've got to differentiate the 2x to get 2. All right, so can you see what's going to be on the denominator? Anything with negative powers is on the denominator. So what's on the denominator is cos of 2x to the half. And what's on the numerator? Well, negative, what's a half times 2? It's 1. So negative sine of 2x. Now, so we've got negative sine of 2x, just write it the way the question was written with the square root, over the square root of cos 2x, and I'm pretty sure they're not going to make you write that in terms of tan. You just leave it like that. Okay, another one. Let's differentiate the following. I'm going to write if y is, I just want to talk about this one. How are you going to do this? And you've got to be very, very careful. You've got two methods here that you could use. I'd go with the safe method. Do you know what the safe method would be? Is expand it first. That's the safe method. We can do both. This is my last one. So let's just do the safe method by expanding. This is a minus b all squared is a squared minus 2ab plus what? What's b squared? Cos squared x. Can you simplify that? Two of them could go together. Sine squared x plus cos squared x is what? Good. I want to finish this one off. So we've got 1 minus 2 sine x cos x. That's what y is. Now you have to differentiate this. How do you do that? When you differentiate 1, what do you get? 0. Minus. I could put my 2 out the front, or I have to use, I've got 2 functions here. So what do I have to use for that bit? Product rule. U is 2 sine x. U dash is. See, I'm differentiating a function in x times another function in x. What do you get when you differentiate that? 2 cos x. V is cos x. V dash is negative sine x. Okay, so here we go. Be careful. I've got 0, take away. Take away the derivative of all of this. So I'm going to keep a negative out the front with brackets. The other way I could have done it is let u be the negative 2 sine x, but I decided not to. What do you want? Do you want to make u the negative? Or do you want, I'm differentiating the one, I get 0 minus, put this all in brackets, and then we'll get rid of the brackets later. All right, so keep the negative out the front. So u times v dash plus v times u dash. 0 take away. What's u times v dash? Isn't it 2 sine x times u? Yeah, negative, yes, times sine x plus, what's v? V is this times u dash plus cos x times 2 cos x. Now, you okay? So it's 0 minus, so I'll just put minus, what have I got? Negative 2 sine squared x plus what? 2 cos squared x. Now, open your brackets now. What have you got? Negative times a negative. 2 sine squared x minus 2 cos squared x. Now, you don't have, it's extension 1 is where they do a rule for sine squared minus or cos squared minus sine squared. You don't know that rule. So you would just leave it like that. You could pull the 2 out if you want. But you can't simplify that.